Good morning students, welcome back to digital signal processing class. In today's class we are going to continue the unit 2 continuation of your Butterworth-Chebyshev. This two part we covered already by using its steps designing, by taking the order of the filter, by taking the transfer function, and by taking the poles and zeros, respective poles and zeros, how do we find out, and then directly we can reach out to the getting the transfer function. So these things we covered in Butterworth approximation and Chebyshev approximation by considering first order. Then second would be by considering that order is even or odd for Chebyshev. If it is even, we use a separate formula for transfer function. We found numerator of transfer function separately, denominator of the transfer function separately. These things we covered in the previous class. In today's class we are going to cover the next concept. How do we design the analog filter? By using two types of transformation. One is the impulse invariance method, second is bilinear transformation method. The first thing, we proceed with impulse invariance method. So in this, how do we find the transfer function directly? So for that, first thing we need to understand how do we design it. So for designing these things, what we are doing, students? So we are writing step to design a digital filter using impulse invariance response or impulse invariant method. For doing this thing, first criteria is that find HA of S. How do we find HA of S? While we talk about the Butterworth approximation, we saw that to get HA of S, we have seen the order. Whether n is 1 order, S plus 1. n is 2 order, S square root 2 of S plus 1. n is 3 order, the polynomial is S plus 1 into S square plus S plus 1. So this is what actually, this is nothing but S domain by assuming critical frequency as 1 radian per second, right? That part we did in Butterworth approximation. Same thing we done with Chebyshev approximation with different formula by considering numerator factor separately and denominator factor separately. So here in this method also we need to find first HA of S. That means whatever the sequence we do have, that first be written in terms of S domain, right? Then sampling rate of that should be in T, capital T, seconds per sample. So this will be T if they gave the value, then you should consider, otherwise T is 1 seconds per sample. That we need to consider. You can consider this one, right? So T we are considering, T is equals to 1 seconds per sample. Similarly, next for solving the analog filter transfer function, we had this formula. What is that? HA of S is equals to summation k equals to 1 to n. For n number of samples, Ck, that is nothing but coefficients. So Ck by S minus Pk. So Ck is nothing but zeros, Pk is nothing but poles. So zeros and poles we have considered and we found HA of S. Then that S domain sequence we need to convert into Z domain by applying Z transform. So the same function we have to apply by Z transform, S domain written in terms of K domain. That is nothing but Z domain. So summation same as it is, Ck is as it is, but this pole, whatever pole is there Pk, that will be written in terms of E exponential factor, Ek Pt of Z power minus 1. This we have to write by using impulse invariance response. Clear? If you had more higher samples, like if they gave higher sample value, for that same thing H of Z will write, but in the numerator same k is equals to 1 to n summation T of Ck by 1 minus e power Pkt of Z power minus 1. So this we will write, students, when we want to write for higher sampling rate. For that only the thing is we need to multiply by T, that is nothing but time domain sequence we have to take. For T into Ck by 1 minus e power Pk of T Z power minus 1. So this particular thing we need to consider for writing the higher sampling rate. So this is the steps we need to follow for designing the digital given filter by using impulse invariance method. In bilinear transformation, same, everything is same. HA of S we have to find. HA of S, not only this formula, only the change here. This two will be changed. In that, if you use bilinear transformation, I'll tell you when we go for designing. But as of now, remember, for H of Z, what we'll do? We will take 2 by T, 1 minus Z power minus 1 by 1 plus Z power minus 1. So this wherever S is there, H of S, that S domain we can convert to Z domain by applying this factor. So this is the way we can convert the given function by using bilinear transformation. This is the second method of digital filtering of that particular thing by using the bilinear transformation. So this is the two methods we left out with unit 2, then unit 2 will be over. So this bilinear transformation and impulse invariant transformation. So by using these two methods, we'll try to solve problems for digital filtering. Let us see one problem, students. So by using impulse invariant response, we do have one problem. For the analog transfer function h of s, they gave one question. H of s is equals to 2 by s plus 1 into s plus 2. So this is our question. So this is the question they gave. Analog transfer function h of s is given. Determine h of z using impulse invariance method. Assume t is equals to 1 second. So we need to find the transfer function, or directly define determine h of z by using impulse invariance method. Assume t is equals to 1 seconds. So they mention these questions, students. So we need to find h of z, right? For finding the h of z, what we'll do? First, we will try to simplify and we'll try to separate the denominator factor. How do we separate? By applying partial fraction. So what I'll do it? We'll write h of s. Given h of s is equals to 2 by s plus 1 into s plus 2. This is our factor, right? So I can write a by first factor a by s plus 1 plus b by second factor s plus 2. What is the next step I'll do? I'll cross multiply. So 2 is equals to a with the first a into s plus 2 plus b into s plus 1. By denominator gets cancelled. I need to find first value of the a. What I'll do it? Put s is equals to minus 2. That is the case 1. For the second thing, put s is equals to minus 1 for the case 2. What I'll get? 2 is equals to a. Plus 2 minus 2 will be 0. Plus b into what I'll get? S value is minus 2. So minus 2 plus 1. This I'll get the value of b. Similarly, I can put here 2 is equals to a into what is the s value? Minus 1 plus 2 plus b into minus 1 plus 1 0. So how I am taking this plus 2 means we need to substitute minus 2. Plus 1 means minus 1. Right? So this is the way we can find a and b by partial fraction. So a is equals to minus 2 plus 1 is b into minus 1. That is nothing but b is equals to minus 2. We found the value of b. Likewise, I can get the value of a. So a would be 2. Directly I'll get this will be 0. 2 minus 1 is 1. So I found 2. So students, we found the value of b minus 2 and a is what? 2. So we found these two poles where we need to substitute in this particular factor. So let it be, this is your equation 1. So in this I just want to substitute wherever a and b is there, the given condition. So we do have h of s is equals to a. I do have is 2 by s plus 1. I do have b is minus 2 by s plus 2. Right? So we segregated, we got h of s or h of s. Next step is that what we need to do, students? So we need to substitute whatever. What is given? h of s is what actually? Summation k is equals to 1 to n ck by 1 s minus pk. So right, pk is indicates what are the two values we do have. First p1 is minus 1, then p2 is minus 2. Like this will take my negative. Plus means minus. We got these two poles. Where we need to substitute this value, we need to substitute in two things. One thing is that here, second, for the second one, what is s value? We need to modify it. S value we need to modify it by looking into its value. So how do we do it? For doing this thing, what we'll do? We'll try to write the denominator factor. So what is the denominator factor we do have? For writing in h of z, how do we write? H of z is equals to t into ck by 1 minus e power pk of t z power minus 1, right? This is for higher samples. For lower samples, we will write as it is equals to summation k is equals to 1 to n, right? The ck we don't know, it's a constant value, so we do have constant here is 2 2. So I can write 2 by 1 minus e power. What is first pole? pk1 minus 1t z power minus 1. This is for the first pole. We found h1 of z. Likewise, we do have second pole. What is the second? Minus 2 by 1 minus e power. What is this value here? Minus 2t z power minus 1. So this is nothing but h of z. So now what we need to do? We need to simplify this. So what we did, students, so wherever s is there, that s value we modified. What is s here? Here s is there, that we wrote 1 minus e power minus 1t z power minus 1. For the second one, s plus 2. So s is 1 minus e power. Why we are writing 2? Because here we do have pole is 2. That 2 we need to mention z power minus 1. This 2 we got it. Next thing is that we need to simplify this. We need to find out the values for it by cross multiplying and assuming t is equals to 1 second. So by taking the t value 1 second, we need to find out the value. So let us see how do we got this. So first you note it down this thing, then I will show you the simplification part to get the answer. So we found two poles values, so we will substitute this thing and we will cross multiply. So let us see how do we substitute and how do we cross multiply and what is the last answer we will get after simplifying. That simplification part you need to do it by cross multiplying the given values. So these two things if you do it, then your impulse invariance response for given h of z can be obtained. So till now what we did, students, first thing we did take a partial fraction. Next thing, after getting the partial fraction, we just want to write it down the value, we wrote it. Then S domain we need to write into Z domain by considering the bilinear factor. By looking into the poles, we do have two poles. So these two poles value we substituted. Next thing, we need to write it down the value for it. So we are writing now what actually we got. So we got h of z. What is h of z, students? So we got 2 by 1 minus e power minus 1t z power minus 1. That is the first thing. Then second, minus 2 by 1 minus e power minus 2t z power minus 1. Right? What is given? T is equals to t given as 1 second. So we remove the t value in both. So I can write 2. I can take outside common. 1 by 1 minus e power minus 1 z power minus 1. Here also I can write 1 to have taken 2 outside. 1 minus e power minus 2 z power minus 1. This way I can write. I'll cross multiply like this. So 2 is outside anyhow. So 1 minus e power minus 2 z power minus 1. Again minus 1 minus 2 minus plus e power minus 1 z power minus 1 divided by 1 minus e power minus 1 z power minus 1 into second factor 1 minus e power minus 2 z power minus 1. So we got this factor. I can cancel this one and this one. I can take z power minus 1 common. So what I'll get? If I'll take z power minus 1 common. So this one and this one I have cancelled. So I wrote it 2 as it is. Z power minus 1 take common. Here I'll get e power minus 1 minus e power minus 2. By denominator is 1 minus e power minus 1 z power minus 1. Z is there in this denominator 1 minus e power minus 2 z power minus 1. So now substitute e power minus 1 e power minus 2 in calculator. Substitute e power minus 1 minus e power minus 2. If I'll do it, if I multiply with 2, I am getting, so this I am keeping here, I am multiplying directly with 2 here. So I am getting this answer as z power minus 1 into, if I multiply this factor, 0.465. 0.465 by, now next in denominator, multiply 1 with this 1. 1 into 1 it is 1. 1 minus 1 into this I can write z power minus 1 common. If I am multiplying this with the second, if I will take z power minus 1 common, what is left here? Minus is already outside, minus 2. Again I will multiply this factor with first, already I am taking z power minus 1 outside and minus, plus e power minus 1, right? And then minus 2 minus plus e power minus 1 into e power minus 2 z power minus 1 minus 1 minus 2, right? I will get this. So at the end, what is the h of z is equals to this numerator z power minus 1 0.465 by 1 minus z power minus 1 with first factor plus something with z power minus 2. So this something is this e power minus 3. E power minus 3 is 0.04976. So 0.04976. This is these two factors. Similarly, e power minus 1 plus e power minus 2, 0.503. 0.503. So this is your actual answer. At the end we got z power minus 1 into this 2 subtraction is 0.465, 1 minus z power minus 1, addition of these two factors we got this, and then e power minus 1, e power minus 2, bases are equal, powers should be added. So minus 1 minus 2 minus 3, e power minus 3 is this factor into z power minus 2. How do we got z power minus 2? This and this, these two are same, that is a z power minus 2. This is whole. This is the second part of it. We wrote it h of z in terms of the numerator and denominator directly. This is for digital filter designing by using impulse invariance response or impulse invariant method. So we will go for next method, that is bilinear transformation method, and how do we design it, that also we will see. So for that what we'll do, we will take the steps are same, only what is a different factor I'll tell you. Then we will go for steps for designing bilinear transformation. So practice as much problem as you can. I'll give some questions for solving that one, and this one you try it, you will get the idea how do we get the answers. So these things also you need to keep in your mind while you are solving the questions. So before that you noted down these all factors, then proceeding for the further it will be easy. N steps you need to remember for solving all kind of questions. So we will write the student next bilinear transformation. The first thing we are proceeding with, what is the next step? Next method is bilinear transformation method. So bilinear transformation method we want to write. For that, what is the first techniques, what is the things we need to remember, that part I'll tell you. First thing is that what is the first step is there in the previous one that is impulse invariance method. We need to find first HA of S. Here also we have to find the pre-vapping analog frequency. What is this called? Pre-vapping analog frequency. What it is I'll tell you. So what is the pre-vapping analog frequency? Omega is 2 by t tan, this is your tan omega by 2. So this is called pre-vapping analog frequency. So the next step is we have to find, this is the first step, if they did not give the frequency as per the given standard, we need to substitute omega value. This omega value they'll give you, we have to find this omega if it is needed. Mostly will not use this thing, but you need to remember for solving the problems it will be useful if they give frequency of omega, that we need to find the pre-vapping frequency. If they ask to solve it, then we will use it. Next, second step, we have to find h of s. Then third step, same thing, we need to find h of z. How do we find h of z? Again 2 by t 1 minus z power minus 1 by 1 plus z power minus 1, right? Wherever s is there, that s domain can be converted into z domain by substituting s factor as this. Wherever s we do have in the problem, we will substitute this in place of s. And what is t? T, if they did not mention, it is 1 second per sample. So 1 second per sample. So this is the way we can convert your given function into bilinear transformation functions. So you just note down this one. So students, in the next class we will do the problems based upon the bilinear transformation. How do we convert this one? Same thing, by using this S domain, they'll give in the question, by using that S domain, we need to write into Z domain by considering this particular function, that is 2 by t 1 minus z power minus 1 by 1 plus z power minus 1. We can use it and we can find out the particular transfer function into Z domain. That is for also digital filters. Clear? So this, after completing bilinear transformation, your unit 2 will be going to be completed. Thank you. Thank you for today's class. We will start this problem in the next unit in the next class. Have a good day.